Welcome to solverfy.
Now in this question, this is a motor whose center of gravity at G point, and this motor is connected to this disc at B point. Over the disc, the belt is passes, and this belt is connected to this wheel at A point. The radius of the wheel A is 50 mm. This C point is a fixed point. This is pin supported, and this C point to center of gravity of the motor is 100 mm. The radius of this disc is 50 mm, and this center of gravity to this C point is 150 mm. The mass of the motor is given as 20 kg. So we calculate the weight of the motor. Weight of the motor is equal to 20 into 9.81. So this is equal to 196.2 Newton. Now in this question we calculate the moment that must be applied by the motor to rotate this disc B when the wheel A is in lock position. So first of all we draw the free body diagram of this disc. This is the tension T1 and this is the tension T2. So this is the angle of contact. So this angle of contact is 180 degree. So in radians this is pi. So T2 divided by T1 is equal to E mu theta, and the coefficient of static friction between disc and belt is 0.3. So this is T2 is equal to T1. The value of mu is 0.3 into pi. This is T2 is equal to 2.5663 T1. This is the equation 1. This is the equation 1. Now we apply the condition of equilibrium. So summation of all the moment about C point is equal to 0, because C point is a pin supported, that is fixed at the ground. So in this direction the weight of the motor acts in downward direction. This is equal to 196.2 Newton. In this direction tension T1, in this direction tension T2. Now we calculate the summation of all the moment about C point equal to 0. So T1 take anti-clockwise positive and take clockwise is negative. So tension T1 and the perpendicular distance is 150 plus 50. Next T2 and the perpendicular distance is 150 minus 50. Next weight, and this distance is 100 mm equal to 0. So 150 plus 50, so this is 200. T1 200 plus T2, all the dimensions are in mm, so this is 100 equal to W 100. So after solving this equation, T1, this is 2T1 plus T2 equal to weight of the motor, that is equal to 196.2. The value of T2 from equation 1, this is 2T1 plus 2.5663 T1 is equal to 196.2. So after solving this equation, the value of T1 is 42.967 Newton and T2 is 110.26 Newton. Now we determine the moment that must be supplied by the motor to rotate the disc B. So moment is equal to force, this is T2 minus T1, and the perpendicular distance is 50 mm. So moment, the value of T2 is 110.26 minus 42.967 into change into meters. So this is 0.050 meter. So the moment that must be supplied by the motor when wheel A is in lock position will be 3.365 Newton meter. This value rotate the disc B when the wheel A is in lock position. So this is the final answer.